Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we are working through a series of problems to help one of my students get ready for his upcoming final. This comes from his second midterm. This is problem number 4. We're asked to find the volume of the triangle formed by the points 1, 1, 1, 4, 2, 4, and rotated about around the y-axis. So one of the key things about working through a problem like this is drawing the picture and understanding how we're going to find the volume, what method we're going to use. And if you remember from your lessons, you've got a couple of different ways to find the volume. One of them is the washer or disc method, and the other one is the cylindrical shell method. And based on where things are, we'll be using one or the other. So draw yourself up a coordinate plane. I've got one here, and sketch out what the figure is going to look like. That is really key. So we've got a point at 1, 1, point at 1, 4, and then a point at 2, 4. So we've got this triangle here, which I'm going to draw in. And this triangle is going to be rotated about the y-axis. And because you have a choice, especially with something like this, if you're being rotated about the y-axis and you want to use the washer method, all of your things have to be in terms of the y-axis. Your limits of integration, the function of how the radiuses are going to change. The other thing you can do is since it's usually easier for us to deal with stuff in the x-axis. If it's rotating about a vertical axis, but everything's in terms of x, then we can use the cylindrical shells method, which we will use here. Okay, so we've got that, and then let's draw its mirror over on this side, and let's show this here. So let's grab these, do a quick copy and paste. And there we go. Okay. So we've got our triangle. It's kind of the cross section. If you were to cut it open, this is what you would see. And then this rotates around the x-axis. So big cylinder, or small cylinder in here, and then a big cylinder out here. Okay. All right, so we got a picture. We know what we're looking at here. This is good. And then let's talk about the function, the equation that we're going to use for this. So for cylindrical shells, you have this equation. The volume equals the integral from one point to another. And then we are going to be adding up shells. And the area of each of those shells is 2 pi times the radius of each shell times the height of each shell. And I write it out like this because I think it makes a little more sense so that you know what you're looking for instead of some random formula that you're trying to figure out how to plug things into. So we need to come up with our radius and our height, and since I know we're going to be working along the x-axis when our limits of integration and our functions are all going to be in terms of x. So let's do this first. Let's just draw in a representative cylindrical shell. So we're going to go from here, so right there, and then we'll have the actuals over here, the mirrors on the other side, and then we'll have this blue cylinder in here. So this is a typical cylindrical shell inside our shape. So what can we say about this shell? Well, I know from here to here that is our radius. And if we look down, all that is just where we are on the x-axis. So this point right here would tell us what our radius is, and that happens to be whatever x is. So that gives us our first thing. It gives us our radius. Now, if we were going about a different line, then we would use the x value to help us to figure out what the radius actually is. Like, if we're going around 1, then our radius would be x minus 1 in this case. But since we're centered on the y-axis, then our radius is just x. So the next thing we want to look at is our height. So the height of each of these shells, well, is bounded above by that line y equals 2, right? So this line right here is y equals 2. So that's y equals 2. And then bounded below by the triangle. So what would be the hypotenuse of the triangle. And so the height then, if we want to write that down, is equal to 2 minus the hypotenuse. Okay, so how do we figure out what the hypotenuse is? Well, that's just an equation of a line, because that's what the hypotenuse is. It's just a line. And so the hypotenuse goes between two different points. So we've got the point 1, 1 down here, and then the point 2, 4 up here. And we can figure out the equation of that line using point-slope form, slope-intercept form, all kinds of things. So let's figure that out first. So we've got the hypotenuse. And that's going to be, let's use point-slope. So y minus, and we'll take the 1, 1. So y minus 1 equals our slope. Now our slope is up 3 over 1. So it's positive 3. And then times x minus the x value of our point, which is 1. So let's quickly solve that for y. So y minus 1 equals 3x minus 3. Add 1 to both sides, and I get y equals 3x minus 2. So there's the hypotenuse in an equation. So now we know what our height is. Our height is equal to 2 minus, and then 3x minus 2. And we'll clean that up a little bit. 2 minus 3x, it's negative 3x, and then 2 minus negative 2, which is 4. So 4 minus 3x. Okay. All right, so now we've got everything in our integral. The only thing we need is a to b. And the triangle runs from x equals 1 to x equals 2. And so that's what our radiuses are going to run from. And so that's what our a and b are going to be. So our volume is equal to the integral from 1 to 2 of 2 pi times our radius, which is x, times our height, which is 4 minus 3x. And there we go. So now we just need to evaluate this and take it in a couple of steps here. So we'll bring the 2 pi out front, integral from 1 to 2, and then we'll multiply the x in, so we get 4x minus 3x squared. And then we'll go ahead and integrate that. So we get 2 pi times integral of 4x is 2x squared, and then minus x cubed. And we're going to evaluate that from 1 to 2. Okay. So let's put everything in. 2 pi, and then 2 times 2 squared minus 2 cubed. And that's our first term. Minus 2 times 1 squared minus 1 cubed. Ha! I made a mistake. Let's go and fix it real fast. Probably all yelling at your screen. No, don't. It's a mistake. Fix it. This is not y equals 2. That's y equals 4. Okay, so let's fix this real fast. So that means that this would be 4 minus the hypotenuse. And this is here, this is 4 minus all that. And so this is 6 minus 3x. Okay. Now let's do some surgery here. So why don't you just kind of leave it and just let the teacher figure it all out, right? Okay, so this is 6 minus 3x, and this is 6x minus 3x squared. So now our integral is going to be 3x squared minus x cubed. And then if we plug everything in, we get 3 times 2 squared minus 2 cubed. That'll be better. And then minus 3 minus 1. Okay, so we get 2 pi times, let's see, that's 12 minus 8 and minus 2. So that looks like 4 pi. 12 minus 8 is 4, minus 2 is 2, times 2 pi is 4 pi. So that's it. Hopefully this clears up some about the cylindrical method and how to use it, and then the pieces that you're getting. But it's really important to make sure you draw the picture and you use that formula and find those height and radius formulas. So that should do it. Thanks for watching, and I will see you in the next video.